Okay, sir.
Good morning, everyone.
Good morning, sir.
Good morning, sir.
Yeah, good morning.
Good morning, sir.
Hi, good morning. All right. So, have you all attempted the paper? Presuming you have attempted the paper, I'll quickly discuss some questions from the paper and we'll go for the next topic. All right, I'll share the questions with you in the group so that you can follow what I'm doing. All right, you have received the wave questions. Let's go to the first pick. Two particles A and B are thrown up simultaneously from the edge of a cliff with velocities initial speeds v and 2v. So I've got a cliff. One particle is thrown like this with v, other particle is thrown with 2v. Okay, look at this, students. He's saying what is the motion of B with respect to A. So initially, till this particle lands the ground, relative acceleration is zero. Right? Till the particle hits the ground, which particle hits the ground first? A. Till that A hits the ground, relative acceleration is zero. When relative acceleration is zero, relative velocity will be constant. That means motion will be linear. So velocity of B with respect to A will be 2v naught minus v naught, which is equal to v naught upwards. So B will seem to go B with V naught upwards to A. So A will see B to be going upwards with A V naught straight upwards till it reaches ground. But once it reaches ground, now relative acceleration is not zero because acceleration of this is zero, but acceleration of B is G downwards. So relative acceleration is not zero. So motion will be parabolic with respect to time. So that's why it's first linear, then parabolic. All right, are you all following the questions you have sent?
Yes, sir.
All
Yes,
right,
sir.
all right. Look at the second question. Two particles A and B move with constant velocities v and vb. Initially, the radius vectors are RA and RB. For the particles to collide, the relation between the four vectors is.
You have completed this one, sir.
Sorry,
I think you have completed this one.
you've done it?
No, sir, you have completed this question, sir, in the previous
All right.
classes.
All right, all right. Then we'll go ahead. Is it okay for others? Can I go ahead? Or you want me to do that question? Shravani, Bhavna, Gayatri, Omkar.
Sir, can you do it once?
Yeah, that's what. Ask. Okay, I'll do it again. See, one velocity of position vector of one is RA, position vector of the other is RB. This is A, this is B. And this would be how much? Like, what will this vector be from RA to RB? RB minus RA, right?
Yes, sir.
Yeah. Now, velocity of B with respect to A should be directed from B to A, or velocity of A with respect to B should be directed from A to B for collision. అంటే B నుంచి చూస్తే particle A should appear as if it's coming directly towards hitting B. Alright. Or A నుంచి చూస్తే particle B should appear to be coming directly and hitting A. So velocity of A with respect to B should be directed from A to B, B to A. Alright. So that means now unit vector should be in the direction of RB minus RA. What is the unit vector in direction of RB minus RA? RB minus RA by mod of RB minus RA is my unit vector in that direction, R cap. Now my unit vector, velocity unit vector should also be in the same direction. Unit vector should be same. Which velocity vector? Velocity of B with respect to A, or A with respect to B, sorry. So velocity of A with respect to B will be directed from A to B. So velocity of A with respect to B should be directed from A to B. So VA minus VB mod, these two should be equal. If I take minus common on both the sides, minus 1 common on both the sides, I'll get RA minus RB is equal to VA, VB minus VA, which is option 4. See, if I read this expression, what does it mean? Velocity of A with respect to B is directed from A to B. And what is direction from A to B? Position vector from A to B, RB minus RA. So unit vector in the direction RB to RA is RB minus RA by mod of RB minus RA, which should be equal to unit vector in that direction in velocity terms. Whether I measure unit vector in this terms or this terms, they should be equal because direction is same. Velocity of A with respect to B, velocity of A with respect to B should be directed from A to B for collision. That mathematically is expressed like this.
Yes, sir.
All right. Okay, next one. Okay, 76. Next third pick. Should I do the third pick or should I go ahead? Read the question, everyone, and try to understand the question because it's a little tricky. Wind appears to blow from north to a person who is going northeast. Northeast direction length V naught though. Wind is appearing to blow from north. Now let the actual direction, this is relative velocity, VR. Now let the actual direction of wind be like this, VW. So velocity of wind with respect to man is VW minus of V man, V naught. That is in this direction. ఇది theta అనుకుంటే ఇది V naught అనుకుంటే this is 45. This is velocity of VR. You understand this diagram? See, relative velocity problems లో ఆ diagram correct relative velocity diagram correct draw చేస్తే remaining sin theta, cos theta, tan theta. Let the velocity of the wind be like this. Velocity of wind with respect to man, velocity of wind be like this. This minus of this is vertically downwards from north. When he doubles his speed, all right, now when he doubles his speed, that moves velocity appears to be cot inverse of 2 east of north. Hmm. Cot inverse of 2 east of north. That is cot inverse of 2. This is VW, V naught, 2 V naught, sorry. All right, this is not drawn to scale. And this is again 45 degrees. Look at this, students. From here, I can get V by root 2. All right, we don't even have to go for complete trigonometry now. We can directly, looking at the options, we can directly squat. Look at this. I've got, this is V naught. So this is V naught by root 2. This is Vx. Hmm. All right. Now look at the students. Options are either east or west. All right. So I don't have to look at the direction to be in general theta. I'll either take east or west. But if I take east or west, if I take west, let's say, I'll get a contradiction. If the particle is wind is blowing towards west, with respect to man, moving with velocity v naught, in northeast direction, Let's look at possible options. Towards east, towards west, towards east. All right. So it's either west or east. So I'll take wind to be towards west, let's say. So wind is going towards left. All right. So and the man goes with velocity v naught in this direction. So my resultant is in this direction. So which is not vertical. For the resultant to be vertical, wind has to be towards east with a person moving with velocity v naught for the resultant to be vertical. So this is v naught. This is v naught by root 2. So option is v naught by root 2 towards, v naught by root 2 is the magnitude and that's towards east. Why did I take it towards east? Because if I take towards west, my relative velocity is not vertical. Look at this. Velocity is towards west with respect to man. This is VW minus V naught plus or minus V naught. VR is this way. So VR is not vertical. VR is vertical possible only when it is towards east. So its velocity is towards east for sure. When I conclude that it's towards east, we can do it this way as well. That will be a little longer, 2 steps lengthier. But look at this. If it's towards east, velocity of wind with respect to man is vertical. So this is my relative velocity triangle. So relative velocity is V naught by root 2 and absolute velocity of the wind is V naught by root 2 and velocity of the person is V naught. And if we were to double the speed, this is V naught Vx V naught by root 2 and this angle is cot inverse of 2. That's what he says. All right, we don't even have to go for this. We can directly look for the options and conclude, no, like from options we can conclude which direction the particle is going, wind is blowing. And from there I can draw the triangle. All right, so towards east makes sense because relative velocity is vertical. If it were west, relative velocity would not be vertical. Look at this, VR is not vertical. It would be vertical only when the wind is towards east. Okay, this is east. This is north. This is east. All right, I'm going for the next pick. The motion of a body falling from rest in a resting medium is described by the equation dv by dt is equal to a minus bv. I think we have done this as well, right? Should I do this again?
No, sir.
Okay. Others? 79th question, fourth pick. Savani, Bhavna, Gayatri, Likita, Omkar. Should I go for the fourth pick or should I go ahead? All right, I'm going ahead. Yes, Bhavna?
So, fourth pick, can you see?
Yeah, okay. Daily 5 problems and a practice change, students. All right. Without practice, no training is useful. I want velocity as a function of time. So I integrate this. dv by a minus bv is equal to dt. I integrate this. When time is 0, velocity is 0. Time is t, velocity is v. Right? Now, how do I integrate this one? Let us say I multiply with v on both the sides, minus b. Now, this is nothing but f dash x by fx. The formula is mod fx, log mod fx, not mod fx, log mod fx. All right. F dash x by fx formula into log mod fx. This derivations and all you learn in calculus class. All right. Or will do when required. But right now, just understand, just remember the formula that which says integral f dash x by fx is equal to log mod ln mod fx. All right. So I've got here log mod a minus bb, which is always positive, under limits 0 to v, which is equal to minus b t. Integral dt is t. I substitute the upper limit and then I substitute the lower limit. Log a minus bb minus log a is equal to minus bt. So log a minus bb by a is equal to minus bt. And then we've got a minus bb by e power minus bt. So I'll have 1 minus bb by a is equal to e power minus bt. So v is equal to a by b times of 1 minus e power minus. Check if this is correct. I could be wrong in this. Yeah, option 3, which is already marked there. Check this correct, students.
Yes, sir.
Okay. So have you understood, Bhavna?
Yes, sir, I understood.
Okay. Good, good. Okay, let's go for the fifth pick. Okay. He says the ball's velocity in this on this ground is velocity u at an angle of 30 degrees. And the fielder runs in the direction of theta with velocity of 2u by 3. For him to catch this ball, velocity of fielder with respect to ball should be directed from fielder to ball. Velocity of B with respect to A should be directed from B to A. All right. That means velocity of this, velocity of B minus velocity of A should be directed from B to A. If the resultant is in this direction, its vertical component is 0. That means this component, 2V by 3 component, vertical component should counterbalance the U sin theta component. Component of U, vertical component of U should cancel out vertical component of 2U by 3 because I've got resultant only in the horizontal direction towards left. So I will have U sin theta, which is U by 2, U sin 30 is equal to 2U by 3 sin theta. U gets cancelled out. Theta is equal to sine inverse of 3 by 4. Is that there? Yeah. Sine inverse of 3 by 4. You understand this point? My velocity of ball, fielder with respect to ball should be directed from B to A, fielder to ball. If the resultant is in this direction, its vertical component should be 0. If the vertical component is 0, that means this component is counterbalancing this component. 2U by 3 component vertically, which is 2U by 3 sin theta, should be equal to U by 2, U sin 30, which is U by 2. So U by 2 is being counterbalanced by 2U by 3 sin theta. That's what I've written. So that resultant is only in the direction directed towards ball. Look at the fourth one. Next sixth pick. See, I'm giving you kinematics again and again because which is very much required for following chapters also. All right. So that you, presuming you have not done proper revision, I'm making you revise. And presuming you are doing chapters initial, you are in the initial chapters itself. I'm giving you kinematics and vectors frequently. All right. Okay. Now he says acceleration due to wind is 4 meters per second towards left, second square towards left. And acceleration due to gravity is downward g. So resultant effective acceleration is towards this direction at an angle of 4 by 10. 4 by 10 is tan inverse of or cot inverse of 10 by 4. What is 10 by 4? 2.5. All right. So this angle is cot inverse of 2.5. Now look at this. For the particle to return to his own hand, the particle should go in a straight line, right? If this is V0, angle between V0 and acceleration should be either 0 or non-zero. Sorry, 0 or 180. It cannot be non-zero or non-180. If it is non-zero, it will go in a parabolic path. I know that. With acceleration, with the axis of the parabola parallel to acceleration vector, which is g effective this way. But for that to come to his own hand, the particle should go in a straight line. For it to go in straight line, the velocity and acceleration g effective should be parallel, anti-parallel. So only then it will come back to his own hand. You go like this, stop and come back. Why is it going? Why is it going in linear fashion in this direction? Because wind is blowing towards left with an acceleration of 4 meters per second square. That's imparting an acceleration of 4 meters per second square to the ball. So if this is cot inverse of 2.5, this is theta required. So theta is equal to cot inverse of 2.5. Is that okay, students? Or do you want me to do it again? Explain it again?
Yes,
Yes,
sir.
sir.
Okay. Explain it again, or is it okay? Guesses for what?
So can you
Sir,
explain
explain
once again?
again.
Yeah. See, velocity, if it's in this direction and G effective is in this direction, let's say. So, and then in that case, this particle will go in a parabolic path with the acceleration vector parallel to the axis of the parabola, parallel to the acceleration vector. You all know this, right? You know this, right?
Yes, sir.
In that case, particle will not come to his own hand. For it to come to his own hand, the particle should go in straight line. For it to go in straight line, my velocity and acceleration vector should be anti-parallel. So velocity, acceleration vector e direction lo undi, which is cot inverse of 2.5. ఇది ఎలా వచ్చింది cot inverse of 2.5? 4 horizontal, 10 vertical. So tan of 4 by 10 or cot of 10 by 4. అక్కడ cot terms ఇచ్చాడు కాబట్టి cot of and tan also see tan for 4 by 5, which is 0.4, which is not there in the options. Cot inverse of 10 by 4 is 2.5. Cot inverse 2.5. So I'm taking cot here. Now velocity should be such that it should be anti-parallel to this acceleration vector. Required is this. So velocity should be anti-parallel to this acceleration vector, G effective, effective acceleration. Why is effective acceleration towards left, inclined with a vertical? If there were no wind, it would fall vertically downwards. Because of the wind, particle is being imparted an acceleration of 4 meters per second square towards left. So effective acceleration is inclined at this angle. So my velocity should be anti-parallel to this one. Only then that will go back, go there, stop and come back to his own hand. Only then the trajectory is straight line. So this is cot inverse 2.5. Theta is vertically opposite angle. Theta is also cot inverse 2.5. Is that okay now?
Yes, sir.
Okay. Vignesh, is it okay?
Yes, sir.
Okay. Sixth one, seventh pick. I think we have done this. Seventh pick, we have done it already. Alright, I'm going ahead. Next one, eighth pick. Please stop me if you want me to do it again. Alright. Ultimately, you should be benefited. It is not that I keep on going or keep on skipping. Okay, మీరు చెప్పండి కావాలంటే చెప్పండి ఆపండి. Eighth one,
ఈ ఎయిత్ వన్ చెప్పండి.
చెప్పడా? Okay. When particle is thrown straight up with velocity v naught, the other particle is thrown at an angle of alpha with a horizontal. Separation between the particles at time t is. See, to get the separation between two particles, I need relative velocity between the two particles. Because they are thrown under gravity, relative acceleration is zero. Because this will fall under gravity, this will also fall under gravity. G downwards and G downwards. G downwards minus G downwards is zero. So relative acceleration is zero. When relative acceleration is zero, relative velocity is constant. So if I find relative velocity and multiply it with time, I'm done with the question. So look at this. Velocity of one, or this is A, this is B. Velocity of B with respect to A, let us do. So velocity of B with respect to A will be VB minus VA. When I have two equal vectors, my angle resultant will be along the angle bisector. That I know, right? And what is the resultant now? This is, if this is alpha, this is 90 minus alpha, right? So this becomes 180 minus 90 minus alpha by 2. This is 90 minus, this is 90, this is alpha, this total is 90 plus alpha. So this one plus this one is 180 plus alpha, 180 minus 90 minus alpha, 90 plus alpha, which is nothing but 90 minus alpha. By 2 is my each angle. Now look at this diagram. V naught sine of this angle is my resultant in this direction. V naught sine of this angle is my resultant along this along the angle bisector. So my resultant will be 2 V naught, V naught sine alpha, sine theta, let's say. V naught sine theta plus V naught sine theta, 2 V naught sine theta. So 2 V naught sine 45 minus alpha by 2 into T is my separation in there. I'll repeat. I've got V naught, velocity, one particle is going this way, the other particle is going upwards. So velocity of particle which is going inclined at an angle of alpha with respect to the particle which is going upwards is V naught minus of VA. VA, I'll flip the direction of VA and add it to VB. When I add two vectors, equal vectors, my resultant is always along the angle bisector. That I know. Now look at this. This is angle with name is 90 plus alpha. So this angle would be 180 minus 90 plus alpha by 2. Because 2 theta is equal to 180 minus alpha, 90 plus alpha. This plus this. Total angle is 180. This angle is 90 plus alpha. So this is equal to this angle by symmetry. So 180 minus 90 plus alpha by 2 is this angle theta. So theta is equal to 90 minus alpha by 2, which is 45 minus alpha by 2. Now my resultant is, if this is theta, V naught sine theta plus V naught sine theta. 2 V naught sine theta is my resultant along the angle bisector. So 2 V naught sine of 45 minus alpha by 2 is my resultant velocity along the angle bisector. Now because relative velocity is constant, I can simply multiply with time to get the separation between them. Velocity into time will give me displacement. Right, separation between them. Because particle B appears to A to go in this direction. Particle A పైకి వెళ్తుంది యాక్చువల్ విత్ రెస్పెక్ట్ టు గ్రౌండ్. పార్టికల్ బి ఇలా పారాబోలిక్ పాత్ లో వెళ్తుంది. పార్టికల్ ఏమో ఇలా పైకి వెళ్ళి కిందకు వస్తుంది. బట్ పార్టికల్ బి విల్ అపియర్ టు ఏ గో ఇన్ దిస్ డైరెక్షన్ స్ట్రైట్ లైన్. Why is it straight line? Because relative acceleration is zero. Why is relative acceleration zero? Because both are going under gravity. Acceleration of each particle is g. So relative acceleration is g minus g, which is zero. Yeah, separation is nothing but distance between them. ఒక పార్టికల్ ఇక్కడ వెళ్ళింది, ఈ పార్టికల్ ఇక్కడ వరకు వచ్చింది. Now this is the separation. Separation is nothing but distance between them at certain time t. Separate అవుతున్నారు కదా. The particles are getting separated. That is separation. Distance between that 2 points after time t is separation. Separation is nothing but distance between two particles. All right.
Yes, sir.
Okay. But what if,
Tenth peak, sir.
sorry,
10th peak.
ఏంటి? Sorry, you said something? I didn't get you. Okay, let's look at the next one. We have just 10 more minutes. Okay, we have done few questions before itself, so we can directly jump to questions which we have not done. Okay, look at the 16th pick. Pseudo force. Students, it's very important that you understand whatever you're doing, everything properly. All right, 10th pick. Okay. 10th pick says two particles are projected with angle or an inclination of angle theta. One is projected as this way with theta, the other is projected horizontally at an angle of theta with the inclined plane. Now, first option is particles which collide the plane with the same speed. Obviously, no, because when this comes down the plane, it will increase its speed. When this goes up the plane, it will decrease its speed. So they'll not collide with the same speed. Times of flight for each particle are same. Both particles strike the plane perpendicularly. None of these. See, for them to strike perpendicularly, this is not the condition. Surely, when this hits this, when this is projected horizontally, this will definitely not hit perpendicularly, right? Perpendicular hit kya that should be up the plane. So this can hit perpendicularly depending on some condition for theta, but this cannot hit perpendicularly because this is coming down the plane with the angle changing like this. So it cannot hit perpendicularly like this. Look at the times of flight. Times of flight is simple to see because what is time of flight? If this is V naught and this is V naught, V naught sine theta by G cos theta. 2 V naught sine theta by G cos theta is my time of flight. For this particle, same thing. 2 V naught sine theta by G cos theta. So the times of flight are the same. Whereas other three options are not, other A and C are not correct. Whereas times of flight are same. So D is ruled out. So B is correct. Is it okay now, Navneet?
Okay, sir.
Okay, I'll go for the 11th pick. Which of the system is at rest? For the system to be at rest, supporting force should be equal to the opposing force. In the first case, supporting force is mg plus mg. It is being pulled with mg. There is already a gravitational force mg on the block of mass m, and which is being in turn pulled with mg. So net supporting force is mg plus mg 2mg. Opposing force is gravitational force on the mass 2m. which is 2 mg. So 2 mg minus 2 mg is 0. So block system A remains at rest. Supporting force is 2 mg, opposing force is 2 mg. So it will remain at rest, equilibrium. But look at this. When this is 2 mg, I replace this mass and pull it with only force 2 mg. That is option C. Even then they are at rest. But option B says this is M. So here opposing force is mg, whereas supporting force is 2 mg. All right. I'm doing it quickly because very simple question. Mass M, opposing force mg, mass M, which is being pulled with mg. So supporting force is 2 mg. 2 mg minus mg is my net force. So there is a net force on the blocks. So there will be an acceleration for the block, each acceleration. And how much is the acceleration, students? For block of system B, what is the acceleration? Can you tell me? Can you quickly tell me what is the acceleration of the system B? I mean, acceleration of the blocks in system B.
0, sir.
Sir, it will be G/3, sir.
G by 3 or G by 2?
G/2, sir.
Or G by 3?
G/2.
G/3, sir.
Okay, look at this. I've got a block mass M, another block of mass M, which is being pulled with mg. So what is the net external force? Mg. By total mass, 2m, which is G by 2. I'm talking about system B, Bombay.
Yes, sir.
System D, what is the acceleration of the system D? Delhi.
G/2.
What is the net external force? Tell me.
Sir, is it G/3?
Yeah, G by 3. mg by 3m. Net external force is mg, 2 mg minus mg, which is mg. By total mass is 3m.
Yes, sir.
So equilibrium lo ఏదన్నాయి A ఇంకా C are equilibrium. B and R D moving with acceleration G by 2 and G by 3. Okay, next one. Which one do you want me to do next?
Sir, can you do the bead one? Ninth question.
Okay, 13th pick. Okay, ninth question.
Yeah.
A bead of mass M is fitted on the rod and can move on it without friction. Initially, the bead is at the middle of the rod. Translation in horizontal plane with an acceleration in horizontal. Hmm. So this is my rod. Acceleration is A naught with respect to rod. main alpha. So when the rod is moving with acceleration a naught towards left, when I stand on the rod, pseudo force on the bead is towards right because my acceleration of the reference frame is towards left. So m times a naught is towards right, mg is towards vertically downwards is mg. Now net force along the rod would be ma cos alpha, mg sin alpha. This is alpha. This is 90 minus alpha. So mg cos of 90 minus alpha is mg sin alpha minus ma cos alpha is equal to mass into acceleration. M gets cancelled out. Acceleration of the bead is g sin alpha minus a naught cos alpha. ఇప్పుడు చూడండి, if this is g sin alpha minus a naught cos alpha, if a naught is not that huge, let's say a naught is 0, the bead will slip down the rod. But as a naught goes on increasing, bead's acceleration down the rod will decrease. If a naught is huge enough for the bead to huge enough to beat the downward force mg sin alpha, the bead will start going upward with respect to the rod. Do you understand that? So how do I get the acceleration? I write force. How do I get the force? I choose the reference frame. Reference frame choose చేసి FBD draw చేశాను. Now FBD is not complete actually. I'll also have a normal reaction. But normal reaction is not coming into picture because there is no friction. Friction ఉన్నప్పుడు you'll have normal reaction coming into picture, usually. Because friction depends on normal reaction. So normal reaction I'll have to consider when, and also normal reaction is perpendicular to the direction of motion of the bead. Bead is moving along the rod. Normal reaction is perpendicular to the rod. So effect of normal reaction along the motion of the bead is 0. So I'll have net force along the rod, which is mg sin alpha minus ma cos alpha. Ma ఎలా వచ్చింది? ma naught pseudo force. Why am I getting pseudo force? Because my reference frame is accelerating reference frame, non-inertial reference frame. Is it okay, Vignesh?
Yes, sir.
I choose a reference frame, I draw the FBD, I write F is equal to ma. From there, I get acceleration. Alright, that's a 3-step procedure. For any N and M problem, choose a reference frame, draw the FBD, write F is equal to ma, get the acceleration. Students, I want you to try the other questions because we have done a couple of questions before. 17th week we have done. How many are remaining? 6 more. Sorry. 19th we have done, 20th we have done.
5 more, sir.
Okay. 4 more. Alright, 17th also we have done. Alright, students. Next class we'll start circular motion and we'll wind up circular motion in a very short period of time. We'll move on to work for energy. So please do not miss circular motion, which is very important for coming up topics. Alright. Let's stop here. Have a great day. Bye everyone. Students, please practice చేయకుంటే చాలా టైం వేస్ట్ అవుతుంది. Without practice, everything is zero. If you've got any doubts, please post it in the WhatsApp. We'll discuss in the next class. ఏ బుక్ అయినా మీరు పోస్ట్ చేయండి. We'll discuss the problem in the next class. WhatsApp లో పోస్ట్ చేసేయండి. All right. All right then. Bye everyone.